In this video, you will learn about the distributive property. Now, as we begin, we're going to start with a real-life example. And then after the example, we're going to go into more detail on how to work with the distributive property. So, real-life example. Let's say you're going snorkeling, and there's 6 of you people, I guess you and 6 of your friends, and it costs $5 to rent the snorkel and $3 to rent the fins. And the question is, what will be the total cost if everyone is renting all the necessary gear? So I guess let's just look at your friends. So looking at what your friends would have to pay. Well, you have 6 friends. All right, so one way to solve is if we take those 6 friends and multiply by the cost of the entire set. All right, so the entire set is $5 plus $3. So we could take 6 times the 5 plus 3, which is 8, to get $48 total. Okay, the other way we can calculate the cost for your 6 friends is we can take 6 times the cost for the snorkel plus 6 times the cost for the fins. So if we do 6 times 5, that'd be $30 total for the snorkel, and then 6 times 3 would be $18 total for the fins. So if I take 30 plus 18, I'd also get $48. So this is an illustration of the distributive property, where looking here at the example 1, the first way to solve, what we are doing basically is we're taking the number in front and multiplying it by both numbers in parentheses. So we'd have 6 times the 5, that would give me this right here, plus, so the plus sign, and then 6 times 3, which would be over here. Alright, and that's the same thing. So the distributive property says I can take whatever number's in the front of the parentheses when it's being multiplied, and then distribute it or multiply it to both or multiple terms inside the parentheses. So here is the rule written in math notation. We have A times parentheses B plus C. And the property says that I take the A, multiply it by both numbers inside. So A times the B plus, and then A times the C. And also the same rule applies if the A is on the right side instead of the left side. So A, the number outside of the parentheses, to distribute I can multiply by both the B, so A times B, or BA, same thing, plus, and then A times C, or CA, which is the same thing. And this is also useful doing mental math. So for example, if you had to calculate 5 times 73 in your head, a way you can do this is with the distributive property. So the way to do this is I take the big number, the 73, and I break it up as 70 plus 3. So what I have is 5 times 70 plus 3. Now for the distributive property, I can do 5 times 70, and then I can also do 5 times 3. So I distribute the 5 to both terms. And then when I do that, I add them together. So 5 times 70, you can do that in your head, because 5 times 7 is 35, and then just add a 0 to it. So that's 350, plus 15, which would be 365. Here's another example. We have 6 times 11.5. What I can do is I can think of this as 6 times 11 plus 0.5. So when I distribute, I have 6 times 11 plus 6 times 0.5. Well, 6 times 11 is 66, and then 0.5 times 6, that's the same thing as 1/2 of 6, which is 3. So I have 66 plus 3, which would equal 69. One more example. We have 6 times 2 and 1/3. What I can do is I can think of the 2 and 1/3 as 2 plus 1/3, and then distribute. 6 times 2 is 12, and then 6 times 1/3 would be 1/3 of 6, which would be 6 divided by 3, which would equal 2. So I have 12 plus 2, which would be 14. Here we have 2 more examples with just regular general algebra problems with the distributive property. So no more mental math for now. We're just going to work with some algebra. So here we have 4 times x plus 3. So to distribute, we would simply do 4 times the x plus 4 times the 3. So 4 times x can be written as 4x, and then 4 times 3 is 12. So my answer is 4x plus 12. Here we have 6x plus 5 multiplied by 3. So in this case, the 3 is on the right side, but the distributive property still applies the same way. The 3 is what I multiply to both things in parentheses. So we have 3 times 6x, and then 3 times 5. So 6x times 3, we have 6 times 3, which is 18. So I have 18x. And then 5 times 3 is 15. So my simplified form, after I distribute, would be 18x plus 15. Now the question is, what do you do if there is subtraction inside? So here is the rule written in math notation. If we have subtraction inside, we do the same thing where we take the a times the b to get ab, and then a times the c to get ac, and then I keep the sign a negative in between. So there's negative inside here. I keep the negative in between the two terms. And same thing applies if the a is on the right side. We take a times b to get the first term, which is ab or ba, same thing, and then a times c, or c times a, for the second term, and then keep the subtraction sign in between. So here's an example. We have 5 times 3 minus x. To distribute, I take 5 times 3 to get 15, then 5 times x to get 5x, and then the sign is negative in between. So it's 15 minus 5x. Next we have 2 times 5x minus y. So 2 times the 5x would give me 10x, and 2 times the negative y would be negative 2y. So my answer would be 10x minus 2y. All right, here is a different looking example. We have 75 times 13 plus 25 times 13. This one you're actually kind of thinking in reverse distributing. We notice that the 13 is in common with the two terms. So we have like this part here and this part here separated by a plus sign. And notice the 13 is in common with both of them. So what I can do is think of this as pulling a 13 out, and then we have something in parentheses left over. What is left over would be the 75 and the 25, and that's separated by a plus sign. So 75 and then plus 25. And notice that is the same thing, because the 13, if I distribute it back through, I have 13 times 75, which is what we have here, and then plus 13 times 25, which is what I have over here. So I'm thinking of reverse distributing. And the 13 can be in the front or at the end. It doesn't matter. Here I put it at the end. And then what I can do here is 75 plus 25, we know is 100. 100 times 13 would be 1300. So using this reverse distributing process, we have made a very complicated looking problem into a very simple problem. And this idea of distributing is important as we progress in our study of algebra, because that is the underlying reason why I can simplify something like this, where I have 8x plus 4x equals 12x. So we have 8x's plus 4 more of them. That gives me 12 total, which makes sense intuitively, but the reason for that is because of your distributive property. So looking here, we have 8x plus 4x. Just like we did in the last example, we could think of this as reverse distributing, where we see they both have an x in common. So I can pull an x out, which by the way is called factoring. We factor an x out, and then in parentheses I'm left with what is remaining, which is the 8 plus 4. And that's what I see right here. So in parentheses I have 8 plus 4, and then the x is outside of the parentheses. Well, 8 plus 4 in the parentheses would equal 12, so what I have is 12 times x. So the reason that this statement up here is true is because of this distributive property. So we would say that 8x plus 4x and 12x are equivalent because they are equal to each other. And we would say that each part is a term, so this is one term, this is another term. Okay, they're separated by a plus or minus sign. So those are two terms, whereas 12x would have one term. There's nothing separated by a plus or minus sign. Now this process of combining or trying to find an equivalent statement that is simpler, that is smaller, is called simplifying an expression. So if I were to say simplify 8x plus 4x, you would answer 12x, because 12x is the simplified form of 8x plus 4x. So here we're told to simplify 8x minus 2x. So what I want to do is combine them to make a simpler expression. So we said based off the distributive property, when I combine these, what I'm doing essentially is I'm taking the coefficients, or the numbers in the front, and combining those. So we have 8 and a minus 2. So we have 8 minus 2, which is 6. So what I have is 6 x's. And that makes sense because if I have 8 of anything minus 2 of anything, I would have 6 of that thing. In this case, that thing would be x's. So I have 8 x's, take away 2 x's, now I have 6 x's. Another example, we have 5n minus 2n plus 6n. To combine, or to simplify, I look at the coefficients. So the 5 minus 2 plus 6. 5 minus 2 plus 6 would be 9. So what I have is going to be 9 n's. Example 11. Here we need to distribute first before we can simplify. So to distribute, I take 7 times n, and then 7 times negative 2. 7 times n is 7n. 7 times negative 2 is negative 14. So I can combine like terms. So we see here a 7n and 3n. Those both have n's in the expression, whereas the minus 14 does not have any n's, so I cannot combine with the 7n and the 3n. So 7n plus 3n would give me 10n, because 7 plus 3 gives me 10. So my simplified form would be 10n minus 14.